In today's class, we will solve a few more important problem sums based on algebraic identities. Here from the given equation, we have to find the value of k. So first two terms, it is in the form of aq minus bq. So if we apply that identity, then it will be aq minus bq, so a minus b, then a square plus ab plus b square. Now if we simplify further, then it will be, so here plus x minus x will cancel each other, here plus y square minus y square will cancel each other, plus 2xy minus 2xy will cancel each other. So the simplified form will be, from the first term, first factor will be 2y, and that will be multiplied by, here we have 3x square plus y square. So now if we put the value of a simplified form of first two terms that were in the form of aq minus bq, that will be 2y, and then multiplied by 3x square plus y square, and then here we have minus 6x square y, and then plus 6y cube, and that is equal to ky cube. So if we simplify further, then here we can see plus 6x square y and minus 6x square y will cancel each other, and from here it is 2y cube plus 6y cube, so 8y cube, and on the right side we have ky cube. So in this equation, if we equate the coefficient of this y cube terms, then we can easily say that k will be equal to 8, and under that condition only this will be satisfied. Now the next question, here it is given that a plus b plus c is equal to 3x, and we need to evaluate this expression. So here what we can do is, we can assume that x minus a is equal to m, x minus b is equal to another variable n, and x minus c is equal to another variable p. So what we can see here is, if we add these three variables m plus n plus p, then what value we will be getting finally? Yes, that will be 0, because here we have 3x. So when we will add them, it will be 3x minus, we have minus a minus b minus c, so minus 1 if we take common, then it will be within bracket a plus b plus c, and 3x is equal to what? That is equal to a plus b plus c, so that those two terms will cancel each other and final value will be 0. And we also know this identity, that mq plus nq plus pq, that is equal to 3mnp, when it satisfies this condition that m plus n plus p is equal to 0. And that's what we have already seen, that m plus n plus p is equal to 0, where m is equal to x minus a, n is equal to x minus b, and so on. So what we can write here is that aq plus bq plus cq, in place of that we can write 3m and p. And what is m? X minus a. In place of n it will be x minus b, in place of p it will be x minus c. And we have another term here, and that is 3x minus a, x minus b multiplied by x minus c. And what we can see here, that both the terms are equal, but they have opposite signs, so they will cancel each other, and the final value of this expression will be 0 based on the given condition. Now we need to simplify this expression, where we have some values for two terms in the numerator, we have three terms in the denominator. Now one way what we can do is, we can calculate the value of the cube value of 0.013, cube value of 0.007, and also the values that are given in the denominator. That is one way, but that is not a good approach. What we can do is, we can apply the appropriate or suitable algebraic identity to ease our simplification. Now what we can see in the numerator is, it is in this format, aq plus bq, and we know that identity is a plus b, and then multiplied by a square minus ab plus b square. Now if we assume that a is equal to 0.013 and b is equal to 0.007, then in that given expression what we can write is 0.013, so this will be aq, plus this will be bq, then divided by a square minus ab plus b square. So if we apply this identity in the numerator, then it will be a plus b, and then a square minus ab plus b square, right? And also in the denominator we have a square minus ab plus b square. So this common terms in the numerator and denominator will cancel each other, so final value will be a plus b. Now let's put all these values of a and b. So it will be 0.013 and value of b is 0.007. So the final value will be 0.02. Now the next sum. Next sum, there we need to prove the expression that we have on the left side of that equation to the right side. So we will start our simplification with the expression that is given on the left side. Now we know this identity that a cube plus b cube plus c cube minus 3abc, that is equal to a plus b plus c a square plus b square plus c square minus ab minus bc minus ca. So if we apply that identity in that given expression that we have on the left side, then what value we will get? So after multiplication and after application of appropriate algebraic identities, we will be getting this expression that we need to simplify further. So what we can see here is this plus x square and this minus x square will cancel each other. Then here we have plus y square and then minus y square will cancel each other. And definitely we'll have plus z square and minus z square which will cancel each other. Then we have minus xy here and we have one more minus xy here. So that will form minus 2xy which will be cancelled by plus 2xy. Here we have minus yz and another minus yz, so that will form minus 2yz which will be cancelled by plus 2yz. And here we have minus xz, another minus xz, that is minus 2xz, and that will be cancelled by plus 2xz. So let's see what are the terms that still remains in that expression. So it will be 2 multiplied by x plus y plus z, and in the second term or factor we have here y square then plus z square plus x square. So let's rearrange this way: x square plus y square plus z square, and then we have minus xy here and then minus yz here, and then we have here minus xz. So again this format is matching with this identity a plus b plus c. Here we have x plus y plus z, then a square plus b square plus c square. We have x square plus y square plus z square. Here we have minus ab minus bc minus ca. Here we have minus xy minus yz minus xz. So that can be written as 2, we have that constant, and then it will be the formula of x cube plus y cube plus z cube and then minus 3xyz. Hence it is proved. Now the next one. Here we have this expression, and the first expression needs to be multiplied by the second expression. So let's rearrange the terms. So 9x square can be written as 3x then whole square. Then we have 25y square, that can be written as minus 5y whole square, because if we take the square value of minus 5, that will give us finally 25 only. And let's take this constant term as our third term. So it will be, or it can be written as 4 square. And then the rest of the terms can be rearranged as 15xy. So it can be written as minus and then 3x will be multiplied by minus 5y. So it will give minus 15xy and then one more minus here, so plus 15xy. Then we have here minus 12x. So 12x means, let's write this way, 3x multiplied by 4 and we have this minus sign, and then minus 20y. So 20y can be written as minus of minus 5y multiplied by 4. So that will give us minus 20y and then one more minus here, so that is plus 20y. Now if we assume that 3x is equal to a, minus 5y is equal to b, and 4 is equal to c, then what we can write here, how we can write here, it will be a square plus b square plus c square and then minus ab minus bc minus ca, right? We can. And now we need to multiply this factor, this expression, by 3x minus 5y plus 4. So 3x is what? A minus 5y is plus b, and then 4 is plus c. So what is this? This is the identity that we already know, and that is a cube plus b cube plus c cube and minus 3abc. Now if we replace ABC by their actual values, then it will be 3x then whole cube. So it can be further simplified as 3 cube means 27, so 27x cube. Here minus 5 cube means 25, then 125, and since here we have minus, so finally it will be minus. So minus 125y cube. Then 4 cube means 16 multiplied by 4, so that will be 64, and from here it will be minus minus plus, and here 4 multiplied by 5 is 20, and 3 multiplied by 3 is 9. 20 multiplied by 9, 180, and then it will be xy. So this is our simplified answer. I hope this class was interesting and meaningful for you. With that hope, I end today's class. Thank you.